Aloha, my name is Jim Patemra, and I'm going to be presenting on behalf of my colleagues listed here, Fernando and Roger at the University of Hawaii with me, and Bob Weller, Al, and Sebastian, who are at Woods Hole. And in this brief talk, I'm going to be making a comparison between the deep temperatures that are measured at three different ocean reference sites, including WATS in the central North Pacific, Stratus in the southeastern Pacific, and NTAS in the western tropical Atlantic. Now, all three of these sites have seafloor or near seafloor mounted seabird microcats, and about 38 meters above the seafloor. And we're confident in these temperature measurements to about 1 millidegree C. And I'll also point out that at Watts, which is just north of the Hawaiian Islands, we're benefited by having a co-located long-term hydrography from the Hawaii Ocean Time Series, or HOT program, and the more recent Aloha Cabled Observatory, which is a seafloor observatory that's cabled to shore, also at Station Aloha. Now, as you all know, recording these deep sea time series are very rare and extremely difficult to maintain. And so what we want to do is take a quick look at how these observations compare to the various model and reanalysis products to see how well these products are representing the variability in the deep sea. And the short answer is not very well. And they're not doing well in the mean, nor the trends, nor the variance from the observations. And so one of the important take-home messages here is that these long-term observations really are critical if we want to understand what's really going on in the deep ocean. The models and the reanalysis are still deficient in this regard. And one final point that we'd like to make here is that this idea, or to dispel this notion that the abyssal ocean is actually this wide, flat plain with not a lot going on, when in fact there is topography in many places, and sloping bottoms and ridges and island chains and so on lead to variability in water mass properties. And the models are going to have to resolve these if they're going to get these signals correct. So in this first figure, what I'm showing is a comparison between the observations at the Watts mooring in red with some model and reanalysis products. Now, the x-axis runs for the past 40 years from 1980 up through 2020. And you could see the observations here from the mooring in red, and then extended back in time in black using HOT and ACO measured deep temperatures. And from this record, we see a mean temperature of 1.103 degrees C with an RMS of about 6 millidegrees C. So within the resolution of the instrument. And just to give you a sense of scale, this distance here is 20 millidegrees C. Now, the rest of these lines here are taken from the various model and reanalysis products. And what we've done is essentially at this latitude and longitude, the location of the mooring, extracted out time series from each of these models at their deepest point. So some of these are not exactly at the depth of the observations, but they are the deepest that the models will go. And you can see there's quite a bit of variety in the mean, in the trends, in the variance. You can see that, for example, the GFDL model has order of magnitude larger variations than the observations. The Hadley temperature reanalysis product seems to be doing okay. I believe this is because they are actually using the HOT profiles to constrain their product, and you can see the difference that it makes when they start doing that and when they don't. These other lines are coming from the various simple ocean data assimilation products, SODA. We have SODA 2 and 3, and the ECMWF reanalysis, ORA S3, S4, and S5. And just a quick point here that just given the shorter record of Watts, we see a cooling trend. But if you look at this over the longer record, this is actually not a significant cooling trend going back in time. Now, if we repeat this analysis looking at the other two ocean reference sites, Stratus and NTAS, the story is the same. Now, Stratus is here in the top left, Watts in the bottom left, and NTAS on the bottom right. And now the axis is going all the way back to 1900 because some of these reanalyses go back quite a bit. And you can see, especially here at Stratus and Watts, you see this very unrealistic trend in GODAS, which is the NOAA operational model. KIOS comes out of Korea. Two versions of HICOM up here in the top. Again, the observations are this red line. And in this larger scale, we could see that these ORA products are doing somewhat better. Hadley Center, not as good as it was doing at Watts. And again, just for reference here, the long-term means and the RMSs. This is a repeat of the Watts record I showed previously, but longer time record. And then finally at NTAS, where again, the Hadley reanalysis is doing much better than the rest. So again, the takeaway here is that these models are really struggling to get the deep ocean temperatures right. And there is actually a lot of variability that is going on down there that we can confidently measure, but only with these long-term time series measurements. Thank you.